So now let's move forward to our second class of antibacterial. So this one, as mentioned in the first discussion, according to the type of activity, this one, aminoglycoside, is a bacteriostatic drug. Okay, so aminoglycoside. Beta-lactams, they are bactericidal. This one, aminoglycoside, is bacteriostatic. So all aminoglycoside antibiotics, they have a very poor oral administration, very poor absorption following oral administration. Okay, we have an example, kanamycin, neomycin, and paromomycin. Okay, they are administered by that for the treatment of GN infections, but we really have to monitor their absorption because they are easily degraded by our gastric juices because they are generally they are polar, ionized, and easily to degrade because of the amines and because of the glycosidic bonds. So these compounds, they are very famous for ototoxicity and nephrotoxicity. And when administered for systemic infections, it has to be given via parenteral administration, usually IM. Okay, usually they're given IM. So according to chemistry, our aminoglycosides, the structure consists amino sugars linked glycosidically. So all have at least one aminohexose, and some have a pentose lacking an amino group. So clinically, these are useful. These are useful because they contain this diaminocyclohexane central ring. And strongly, they are basic compounds due to the presence of amino. And they are highly water soluble. As I've mentioned, they are polar. It distributes well into most body fluids but cannot reach central nervous system, bone, fatty, or connective tissues. And they tend to concentrate in kidneys and are excreted via glomerular filtration. Now let's just relate high water solubility and high kidney excretion or high concentration in kidney elimination. That property leads to the explanation of nephrotoxicity. Okay? So if our patient has bad kidney function, then we should not give aminoglycosides really as a first choice because it's a very polar drug, it's highly water soluble, it's excreted, it can concentrate in the kidney because it's water soluble, and if our kidney fails, then it cannot excrete our drug there. It can cause another problem. So aside the fact that it can cause nephrotoxicity, it can also cause accumulation later on. So this is what our parent aminoglycoside looks like. So they a lot of connections. These are glycosidic bonds. Merong mga label dyan, glycosidic bonds. And we have those in circles and in yung mga nasa circle, these are amino sugars. Okay? These are yung ating amino sugars na sinasabi dyan, at least one amino hexose and other pentoses. So we have hexose here, 1. So at least man. So we have 1, 2, and 3. And then we have a pentose. Okay, so this is our pentose lacking the amine. So the amine, we have NH2, NH2, NH2. And how would you say it's hexose? Because it's 6-membered. 1, 2, 3, 4, 5, 6. So hexose. This is our oxygen, hydroxyl, hydroxyl. So in this structure, we have 3 hexoses, amino, sugar, and then 1 pentose without the amine. Okay, so that is how aminoglycoside parent compound looks like. glued together with the glycosidic bond. Now we have neomycin B and neomycin C. And then we have different places for substitution we call as R1 and R2. And R1 and R2, we have here R1 and R2. Can you see it? Here. R1 and R2. So that is the place for substitution for, again, enhancing the spectrum of activity, for enhancing the absorption of our drug, and for the development good drug. So for neomycin B, we have here R1. Yung kanyang R1 is a methyl amino, and then we have hydrogen here. For neomycin C, we have for R1, they just switched with the location. The hydrogen is in R1 and the methyl amino is in R2. So moving forward again, it's amino sugars linked, di ba? Glycosidically. So usually, pwede siyang 3 rings, sometimes 4 rings. So it's a combination of our hexose, amino hexose, and pentose. So these are the aglycones of the aminoglycosides. So we have our 2-deoxystreptamine, and we have streptidine. So when you say aglycones of amino sugars, yan, meron ito yung mga active compounds that helps with the activity against our bacteria. So these are required for our bacteriostatic action. So we have 3 families under aminoglycoside. It depends now in our aglycone. So streptidine aglycone here will comprise the streptomycin family. Okay? And then 2-deoxystreptamine will have the neomycin family. And then also we have the kanamycin and the gentamicin family following our streptamine aglycone. Okay, so again, the 3 families under aminoglycoside, following the streptidine aglycone, we have streptomycin, and following our streptamine aglycone, we have the group of neomycin and kanamycin, gentamicin. So we have here S2, S1, S2, S1, and S2, S1, S3. These are other amino sugars. Sabot, ibig sabihin yan, sugar. Sugar 1, sugar 2, and sugar 3. So it can be 3 sugars linked together or 4 sugars linked together. And as you can see in the group, it's only the neomycin group that has 4 sugars. So there are a lot of examples under this group too. Yeah. So let's move forward to the structure-activity relationship of the aminoglycoside on the different rings. So constant, meron tayong 3 rings for all 3 families. So activity lies on rings 1, 2, and 3. So remember that ring 1 is for broad spectrum activity, primarily that is the primary target for inactivating enzyme. So remember, ring 1 is the responsible for the antibacterial activity, but also ring 1 is the target of the inactivating enzyme, or yung kalaban, siya yung mismong sword ng ating aminoglycoside, kaya doon din ang target ng ating inactivating enzyme. So for this one, in kanamycin groups, diba si kanamycin has 3 rings only or 3 sugars only. It's under our streptamine aglycone. So it has R1 and R2. So in the ring 1 here, meron siyang addition of NH2 or the amino. In kanamycin B, both R1 and R2 are substituted with amino, and our kanamycin C, only one substitution for amino. Another upgrade on our aminoglycoside is this methylation at either 6 carbon or 6 amino. It will confer resistance to enzymatic acetylation and cannot reduce its antibacterial activity. An example is for our gentamicin complex. So, methylation at either, when you say methylation, you add methyl group. So where is our methyl right now? This one here. Methylation at the 6 carbon. This is the 6 carbon. This is 6 carbon, and then this is 6 amino. So what happened here is methylation or adding of methyl group in our ring 1. Okay? Adding of methyl group in a ring 1 allows resistance to enzymatic acetylation. The next one is removal of 3-hydroxy and 4-hydroxy on both our kanamycin, gentamicin, cyclomycin, natalmycin to confer resistance against phosphorylation this time. So kanina, it confer resistance to bacterial enzyme. This one, the removal of your 3-hydroxy and 4-hydroxy confers resistance against phosphorylation and does not and removal of this 3-hydroxy and 4-hydroxy does not affect antibacterial activity of the drug. So, the phosphorylation process, obviously, it targets our 3-hydroxy and 4-hydroxy. Kaya, it will be removed na lang, tanggalin na lang natin so that our drug will not undergo phosphorylation and inactivation in the future. Kahit tanggalin natin siya, our aminoglycoside will still have the same antibacterial property. So those are the alterations or upgrade in ring 1. Now let's proceed with the ring 2 or the deoxystreptamine ring. There can be few modification of functional groups just like what we have discussed in ring 1. Pwede yung mga na-discuss ko kanina sa ring 1, pwedeng gawin natin sa ring 2. But less common to occur, or we have few products that has ring 2 modification. Okay. Now on ring 3, it is less sensitive to structural changes. Okay, so let's have now ring 2. So ring 2, acetylation pa rin. Yan. Acetylation of one amino group. When you say acetylation, that would be adding of your acetyl group. Okay, ito siya si acetyl, COOH. So addition of acetyl group in ring 2 is one upgrade that will allow our aminoglycoside to have an improved spectrum of activity and resistance to enzyme. Okay, now for ring 3, another thing that we have added here, though it is mentioned kanina that it's resistant to structural modification, but still, it's not impossible to add something on the ring 3. So the two functional groups activity, we can add amino, hydroxy, and hydrogen. So pwede tayo mag-add dito ng amino, hydroxy, and hydrogen. So each amino will increase better action compared to hydroxy, compared to hydrogen. And then the 3 amino group can be primary or secondary type of amine, which are active. So this one, this is a primary amine. You can change it later on with a secondary amine. And then we have 4 hydroxyl group that can be axial or equatorial. So ito yung C4. C4 hydroxyl group can be axial or equatorial. Stereochemistry placement of the drug. It's not substitution, but the arrangement. It has a bearing also in drug upgrade or development.